Data preprocessing is the process of cleaning, organizing, and transforming raw data into a structured format suitable for building and training machine learning models. Hello everyone and welcome to the Machine Learning with Python Ignite series. I am Narendra Kumar Sharma. We will start by learning and doing data preprocessing in Python. I am very excited to begin with you the machine learning journey. We will talk about the machine learning process. There is a specific step-by-step process that we typically always follow when building machine learning models. So let's have a look at what this process entails. This process has three main steps. The first one is called data preprocessing, and here we import the data, we clean the data, and we split the data into training set and test set. A quick note is that in this video series, we won't be focusing much on cleaning the data. That's because the data that we will use is pre-cleaned. So that we can focus on other skills related to machine learning. But keep in mind that in real world situations, cleaning the data is quite an important step. Next, we move on to modeling, where we first build the model, then we train the model, and then we make predictions. So this is the fun part of machine learning, and in this video series you will get a great exposure to several different models and you will be able to practice your skills there. And finally we move on to evaluation step. We will calculate some performance metrics and make a verdict about our model, whether it's a good fitting model and if it works well for our data or not. And this is a very important step to make sure that the models we build really serve the purpose that they are designed for. So that's the machine learning process. Now we will talk about the importance of splitting the data into a training set and a test set. Let's imagine that you are tasked to predict the sale prices of cars, and that is your dependent variable. And your independent variables are the mileage of the car and its age. And in your data that is supplied to you, you have 20 cars in total. Of course, that is not a lot, but for understanding purpose for our example, that will be sufficient. So what splitting your data implies is separating a part of your data out before you do anything with the data. And usually that is about 20% of the data. So since we have 20 cars data in the given data set, here that is about 4 cars that we separate out. So that means 80% will be our training set and the separated 20% will be our test set. We will use our training set to build the model. So in this case, we are building a linear regression, and then we will take the cars from the test set. We will apply our model to them. The cars data in the test set haven't been part of the model creation process. So the model has no information about these cars. And now we are applying the model to them, and it is predicting certain prices. But the good thing is that because this is something we separated in advance as part of the data that was given to us, we know the actual prices. So now we can compare the predicted values which were generated using the model that has never seen these cars before, and we can compare that to the actual values. And from that we can evaluate our model. Is it doing a good job? Is it doing not so good job? And do we need to improve it? And that is how we split a training set and a test set. And that is why it is important to do data splitting into training set and test set. Now we will talk about feature scaling. Now, before we dive into the technical aspects of feature scaling, I would like to present you with an image that hopefully will help you remember what feature scaling is applied to. Even without knowing anything about feature scaling, remember that feature scaling is always applied to columns. So feature scaling would be applied to this column, to this column, and to this column. Feature scaling is never applied across columns. So you would never apply feature scaling to data inside a row. Just remember, feature scaling is always applied to columns. Now let's have a look at what feature scaling actually is. So there are multiple types of feature scaling, multiple techniques. So we are going to look at two main ones: normalization and standardization. Normalization is the process of taking the minimum inside a column, subtracting that minimum from every single value inside that column, and then dividing by the difference between the maximum and the minimum. So basically, every single value in a column is adjusted this way, and you will end up with a new column or an adjusted column with values which are all between 0 and 1. Standardization, on the other hand, the process is similar, but instead of subtracting the minimum, we subtract the average and we divide by the standard deviation. Standardization transforms data to have a mean of 0 and a standard deviation of 1. In a normally distributed dataset, approximately 99.7% of all values lie within 3 standard deviations of the mean. As a result of all the values, or almost all of the values inside the column, will be between -3 and 3. If you have some extreme values or some outliers, then they can end up outside of these -3 and 3 boundaries. So that's normalization and standardization. We will have a look at normalization. Now, let's imagine we have a data set where we have two columns: annual income of a person and their age. Just simple data with those two columns for simplicity's sake, and we are only going to have 3 rows. We are going to have a red person, a green person, and a blue person. Now, here is the data. We have red person. Red person is making 70,000 a year and their age is 45 years. Green person is making 60,000 a year and their age is 44 years. And blue person is making 52,000 a year and their age is 40 years. Now the task at hand is going to be slightly different to the regressions and classifications. The task at hand is to see which of the two people to the green person is more similar to just based on this data. Would you say that the green person is more similar to the red person? Or would you say that the green person is more similar to the blue person? This is more relevant for the clustering tasks or clustering algorithm that we will cover later in this series. But it is just a simple illustrative example that we are going to use here. We are going to talk about it here to show importance of feature scaling. If you would like to pause this video, please go ahead and try to see, would you group the green person with the red person, or would you group the green person with the blue person? Now let's have a look at it together. Let's look at the differences. The difference here in salary is 10,000 and here it is 8,000. And in the terms of age, the difference between the green and the red person is 1 year, and between the green and the blue person is 4 years. Now what can happen with unscaled features, as we can see here, is that the unit values of one column can be so much larger than the unit values of the other that it might overpower. So for example, we can see that the values of 10,000 and 8,000 are much greater than the values of 1 and 4. So we might make the erroneous conclusion that, okay, we are going to ignore values 1 and 4 because those are such small differences compared to 10,000 and 8,000. We are going to focus on these large magnitude numbers, 10,000 and 8,000, and out of them we will say that the green person is clearly closer to the blue person because that value is 8,000. It is 2,000 less than the value of the difference between the green and the red person. And as a result, we would group the green person with the blue person. Now we don't want this or similar things happening in our algorithm, and that is why we need to normalize variables because we cannot compare. Right now we are comparing salaries to years. It is like comparing apples and oranges. These are known comparable things. What if age was expressed not in years but in minutes? Then those values would be much higher, or in seconds would be even higher. And even if you have the same units of measurement like rupees and rupees in two columns, they still might not be comparable because they are relating to different things. So it is important to scale your features. So let's apply normalization. As a quick reminder, this is what the formula for normalization is. We are going to apply it to the columns one by one. So we are applying it to the income column first. After normalizing, this is the result. Our values will look like this. And once we apply it to the age column, our values will look like this. So from here, we end up here. And now we can compare normalized income and age values. Based on this data, which do you think the green person is closest to? Well, I think the answer is obvious. The green person is almost right in the middle between the blue and the red. They are at 0.444, whereas in the age column, the green person is closest to the red person, and it is very clear. That's a quick illustrative example, very simplistic, but yet illustrative example of feature scaling. If you enjoyed this video and want to see more like this, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below. I look forward to seeing you back in the next video. And until then, enjoy machine learning.